Now let's see how cell potential is connected to Gibbs free energy. So I want to start by reminding you that we use some different terms for cell potential. Electromotive force for the cell, or we abbreviate it E cell. So anyway, if the EMF for a cell is positive or negative, is that spontaneous? And remember that spontaneous means that it occurs without you doing anything to it. And because it occurs spontaneously, it can be used to do work. So when we're talking about a cell potential that is spontaneous, that means it's going to make a good battery. You can use it to create or give off energy. Anyway, so what is more favorable? If the electromotive force is positive, then the reaction is spontaneous. If it is negative, if you calculate it and it's negative, that means that the reverse reaction is spontaneous, not the one that you have written. And just a reminder, what about the change in Gibbs free energy? What is spontaneous for Gibbs free energy from before? We learned that Gibbs free energy, if it decreases, the reaction is spontaneous. So a delta G that is negative is spontaneous. And so we can make a connection between the E cell potential and its sign. It should be positive, and Gibbs free energy be negative for a spontaneous reaction that can do work. So now we're going to see how we can relate Gibbs free energy to our cell potential. And sometimes instead of saying the change in Gibbs free energy, we call that the maximum amount of work that it can do. In other words, the change in Gibbs free energy gives the energy that can be released spontaneously. So this is the same thing, is the change in Gibbs free energy is the maximum amount of work that you can obtain when the charge moves due to a potential difference. Okay, and then we see that this has a negative sign here. And that makes sense because if our cell potential is favorable, it's a positive number. And so we're going to need this value to come out negative to give a negative delta G, like we said we need for spontaneity. So there is a negative sign there that's important. This N is the number of electrons being transferred, and we will look at that, but basically you can tell by the balanced half cell reactions how many electrons are being transferred. This capital F is the Faraday constant. And that is the charge of a mole of electrons. And then, of course, our cell potential, the E cell that we use, is the EMF, and we know how to get those.